Hello and welcome to another video. Today we have an Asrock B450 on our bench, a gaming K4, and this came from a reviewer from the Netherlands, and he said that this board was turning on and off, so that there seems to be some problem with some power delivery here. And yeah, I want to start with doing the usual resistance checks. So let's get our probes. Going to put one probe on ground, and let's start at the 24 pin connector. So let's probe 3.3 volts, and we see kilo ohms and rising. Let's probe 5 VSB. That has high resistance, that is good. Then 12 volts, kilo ohms and rising, and 5 volts. 560 ohms is kind of low, but could be fine. Let's go further to the 12 volt for the CPU. No short here. And from the 12 volts into the actual phase. Seems to have high resistance. That is good. Okay, we have no obvious shorts on this board. So we could now go over to passive power consumption then. So let's get our power supply hooked up to here. And we're first going to do it without a CPU. So let's have a good look at the power consumption together. We have 110 milliamps. That could be fine because we have LEDs right here. So this looks fine so far. Let's check if some of the voltages are already running like they should be. So let's see if I can probe 3 VSB somewhere here. Yep, 3.3 volts. I just check in a slot from the PCIe. Let's see. But without a CPU, many things probably won't start up. 1 volt right here. Interesting. 1 volt. What would 1 volt be? Because we have VDDP, which is like 0.9, but it could also be 1 volt. Interesting that it's just 1 volt. Let's see if this is supposed to be the 1.8 maybe. No, the 1.8 volts is present at the BIOS chip. I'm just probing one pin at the BIOS chip, and it has 1.8, so that is fine. Interesting. Well, then let's get a CPU actually into here and see if that voltage changes. We start off with the 2200G in here. So got a CPU in. Let's put a stick of RAM into here. And let's see again for the power consumption. 160. That is kind of high, to be honest. But with the LEDs, it might be fine. Let's see again for... Yeah, now this is more like VDDP. 0.99 volts. Okay. Let's check some more inductors that we see here. But this one is also not starting. This seems like this could be VDDP. There's an inductor right under the memory. So I would expect it to be VDDP and not 1.8 volts because we probed 1.8 volts at a different place, even though I cannot really see where 1.8 volts originates here. Yeah, I guess we're going over to try to power this board on and see if we have a reaction to the power button and how it reacts. So let's get a power button onto here. Okay, let's see. Hitting the power button. No reaction to the power button. That's a bummer. Well then, if we don't have a reaction to the power button, I would go over in order to see for probably missing components somewhere. Let's have a quick look if... Yeah, we have power, we have voltage at the power button. So that definitely goes low when we press it, but no reaction. Okay, so let's then go under the microscope and see for some see for some knocked off components if you can find anything on this board. So let's look together. Very interesting that this board looks like greasy all over the place. Hopefully this hasn't been really messed with. We are currently under the CPU socket, as you can see right here. Let's have a good look here if we can find anything. This might be an important place that we get to later, because I think this is a dual AND gate, this 5 leg component right here, that is responsible for the S3 state. So a power state that tells the board what should be powered on and what not. And that is very necessary for starting the board up, for it to have a reaction to the power button. Really don't know how it can be that this board looks so dirty just. Let's see, this is now the PWM controller, where we are. This is just some sort of string. Let's remove that. Would be interesting to know how this board gets to this state where like it all looks greasy. Okay, let's go to a different position. Let's go to where the BIOS is. Has this BIOS chip been soldered too? It might have been. Interesting. Okay, there's definitely scrapes to the left of the board right here. And we know what that means. That is close, always gets close to the SIO area. Oh yeah, there it is. Yep. I bet you that might be a voltage or something similar for the SIO itself. Has this SIO been replaced? Because it looks crooked. Look at the top right. Those pins. Like the ones right there. But yeah, there's definitely a resistor that is dead on here. I think I have a board view for this board because I also have one of these boards actually as a donor board lying around. But let's have a quick look at a board view to find out what this could be, what this resistor is for. So here we are at the board view. So this is the SIO area, and we are missing this resistor. Yes, this is for battery and SKT OCC. As far as I know, this somehow connected to the CPU, if I'm not mistaken, and to the SIO. Something about the the SIO knowing that there's a CPU in here. Let's see, there's a 0 ohm resistor. Yeah, and it goes to the CPU. That is some kind of showing or knowing for the SIO that there's a CPU plugged into here. And we're missing this voltage here because there's battery voltage or like 3.3 standby that will be here, and that pulls up this line. And this is a 1 meg ohm resistor. So let's see if I can get a 1 meg ohm. And here you can have a great look at my cat. Just sitting there with me trying to fix the board. Get yourself a cat that does things for you like that. So I actually don't have any of the 1 meg ohm in stock, but obviously donor boards got me covered in this case. This is an MSI board that I love to keep taking parts of. And that is way too big of a tip to take that off. Let's see right here. Adding leaded solder to both of its sides. We need this resistor right here. And got leaded solder onto there. Now we go over to put a little bit of flux onto there. And we are going to hot air this off. And then also we need to put it on to the position of the acceptor board. So let's get our hot air and get a fine pair of tweezers so we can pick this all out. So we're going to probably melt plastic here, but I don't really care because, as I said, this is just a donor board. Come on, let go. There we are. And putting the donor board away, let's go over to our receiving board, where the component should already be placed. Let's see, did I hit the right spot? It should be around here somewhere. I put it down. Oh, here it is. I actually hit it very well and I couldn't see the resistor. It's just here. Okay. So, let's park this resistor somewhere. And it sticks to my tweezers very well because the flux that I have is very gooey. As soon as yeah. So, there's the resistor. Let's then go over to our soldering station again. And we're going to prepare the spot where we are soldering. Right here. Get the remains of the old one off. So there's nice leaded solder. And now we're going to take this resistor. Going to put it into here. I know that with my flux it's very reflective and hard to see. I did get like this polarization filter, as you can see, which makes things very different. But it mostly just gets dark. You cannot, like, somewhere with here, you would want to see it, but it doesn't really help with the flux. You can kind of see the resistor better, and the flux isn't as reflective anymore, but it's really hard to see like that also how it is. If you have any suggestions what to do uh, uh, to have it like more visible, let me know. Like, one thing I can say, changing fluxes is sadly not an option because of I have a big supply of this flux, and yeah, I like to use this flux. So yeah. So let's reflow it now into place. There it is. Nicely flown into place. And let's clean it up now. Get our nice little nano sponges in here. So the resistor is on. Let's check for its resistance. That I picked the right resistor right here. Should be about 1 meg. Yep, as you can see, pretty much 1 mega ohm. That is good. Let's then go to the overhead camera again, and let's see how this board now reacts. So let's see. We are hitting the power, the passive power consumption, 160 milliamps, and my device froze. 1 second. There we are, 166 milliamps. Just what we want to see. Let's see now if we have a reaction to the power button. So let's see. Still no reaction to the power button. Wow. Okay. I didn't expect that. I actually thought that would be it because I had exactly this happen before. So, well, I guess there will be more than only this. So, time to go under the microscope yet again. So, I will quickly take a look myself if I can find anything special here. If I find anything, I will get you back into here. So, while messing around, I went looking for some voltages and everything looked fine. And I went ahead to try out the following thing, which is to manually short the PS on. I have this 24-pin adapter that takes 12 volts and puts it to 24-pin, and I soldered a button onto here. This shorts the PS on. So all this does is connect the green wire to the black wire on a PSU to jumpstart it, and have a good look what happens when I manually jumpstart. So I will have to hold the power button here, and we can see 2.4 amps, 4 amps, resetting, 2.4 amps, 2.5 amps, 4.7 amps, resetting 2.6. And let's see, 4.8. And a BIOS screen, an actual picture. So what is happening is that everything on this board works, all of the voltages, there's the BIOS actually, but the PS on is not being triggered to go low. So there's probably some connection missing going to the PS on. And what we are going to do is we're going to trace that fault backwards. So we're going to go from the 24-pin connector and see where the logic from it goes. And as you can see, still the cat sitting right behind me and fixing boards with me. Get yourself a cat. So let's go to the board view. So let's see. The pins that we are shorting is this pin and this ground. This PS on is where it's at. So let's see. It has one capacitor to it. That doesn't matter. It has one 1K ohm resistor that pulls it to 5 VSB. This has to be good because if it works like we did with pushing the power button, that means we're pulling a potential low. So this is definitely there, this 5 VSB. Let's see. There's a 33 ohm resistor right here that connects then to the SIO. We have to see that this connection is actually proper, that this resistor is proper, and that we have a connection from that side of the resistor all the way to this pin. These are the important things that we need to check now, and then we can also check from this to that pin. So let's go over to the microscope again. So here we are. Let's check in resistance mode for the resistance of that 33 ohm resistor, which is I think this one right here. Is this open circuit, this resistor? No, it is not. 33 ohms, 34. That is fine. Okay, so because that is fine, let's check in continuity mode then. We need to see where this resistor goes. And it probably goes to what? The second pin here? The first one? Is that correct? Let me see. No, that wasn't the red resistor. The one that I'm looking for is this one. This one, and let's see, where does it connect? To the second pin. So we definitely have a connection to the second pin. Is that right? Yes. So, and then the other thing that we have to see is from this side of the resistor to the fourth pin. And that connection is also there. So the connection between the SIO and the 24-pin adapter is there. So this probably just isn't being pulled low. Let's confirm that. So let's get power into here. Let's see. We want to see a voltage right here. We have 5 volts. And when pulling this low, pressing the power button, nothing happens. Okay. So the SIO isn't reacting to the press of a power button. It isn't pulling this low. Let's then see for the input of the SIO. So if it actually can read that power button. So back to the board view. Let's see right here. Most of the time the pins are very close to each other. There's pin 63 is OPS on. So pin 63 is OPS on. And then there's a little bit lower down, pin 61, O power button in. I'm pretty sure this is the one that comes from the actual power button. So there's a 100 ohm resistor. And then a 0 ohm right here. Going to SIO PS in. Going to an MCU. Interesting. And then also there's a pull-up to 3 VSB. Yes. and there's another 0 ohm that goes to the front panel. So we will have to see if the voltage that is right here goes low at this point of the SIO. So back under the microscope. So let's see at this fourth resistor, if we have 3.3 volts right there, and we do, let's see if this gets pulled low. No, it doesn't. I'm pressing the power button currently, and it does not go low. Oh, it does go low. Okay, never mind. I just couldn't. Yeah, I didn't hit it right. It does go low. So that's really bad. Because this probably means that that our SIO has a problem. So it does get the signal that it needs, and it sees that it goes low, but doesn't react. That is bad. And this probably has the same thing then. Let's see. This is probably the voltage. Let's pull it low. Yeah. So this also sees the voltage going low, and it doesn't react. That is bad. I'm really not looking forward to replace an SIO here. There might actually be something different faulty with this SIO. It might not be the chip itself, but it might also just be the chip. This diode here looks awfully soldered in. I probably want to just clean off the area in general and then have a good look once more. I think I just found it. I just messed around with a resistor that looked like it got damaged, and I'm pretty sure it did. So, have a good look at the power consumption. There's this resistor right here, right next to the resistor that got knocked off, and it looked really off. If I probe its pad right here, is it that? Should it be this one? Hold up. If I probe right there, oh, nothing currently. Let's see. I just had voltage here. What is this? Just when I had, just a second ago, I had voltage when probing this. There it is. We have voltage right here. 3 volts. Almost 3 volts. And when looking at this resistor right atop here, I have very low voltage. So I thought that connection right there is bad. So what I did is I used my I'm using my probe to short that to each other, and now I'm pressing the power button and it turns on. 2.5 amps. I'm not pressing anything, my hands are free, and the board is turning on by itself. We're going to have an updated screen any second. So what actually happened is that this resistor also got damaged, but it was really hard to see that. This one was obvious, that one that we replaced, but that one wasn't. And yeah, with deduction of the 2.5 amps, with deduction of when putting PS on low by ourselves, that it worked, we could figure out that the PS on had a problem and could backtrace it like that. There could have been an instance where the actual SIO is faulty, to be honest. I think there it is. I think it just posted in that direction. Yeah, cannot really show to it, but yeah, it just posted it is on. It could have been that the SIO is faulty, actually. I really expected that the SIO is actually at fault here, but it isn't. And me just tapping just turned this off because that solder connection is so weak. So let's resolder that. And yeah, I thought that we would need to replace the SIO because it does get the input signal for the power button, and the output signal is not there. So I thought it's just the SIO that has a problem. But actually another signal was missing for the SIO to go further. And yeah, this was just, I cannot really tell you, this was just a bit of luck and a bit of knowing that we had a problem there before and having a look at that. So let's let it solder onto there, reflow it, and hope then that our problem is gone. So let's resolder it. And now let's reflow it just to be very sure. So there it's reflowed. And this should be it for our problem right here. Let's clean off the area. And area is clean. Let's go to the overhead. So let's see, 160 milliamps, pressing the power button. And you are kidding me right now. Why isn't it working? This board is really taking the piss. Let's see. Let's press at this area a little bit and see if it turns on. That resistor might be broken actually. We might need to replace that resistor just because this isn't working. Let's have a quick look under the microscope once more. Let's see if just bridging it will actually work. So let's stop guessing and let's see what this resistor is actually at. Okay, this has very high resistance. This is probably another 1 meg ohm resistor. No, it's just open, huh? Yeah, I think the resistor just completely... Yeah, the resistor died. There it is. Now I get 0. But going here, I get infinity. So the resistor is damaged right at the top right there. Let's see. If I go to my lowest range, and if I actually go from there to there, it probably will show 0. Yeah, 0 right there. But going from there to there, it's not 0. Ah, the resistor just got destroyed. Let me quickly see in the board view that this is a 0 ohm resistor. Have a look at the CAD meanwhile. And yeah, let me confirm that. And yeah, a 0 ohm resistor. Oh, this resistor is throwing me for a loop. So what we're going to do, we're just going to get rid of that resistor. We're just going to bridge that this here. Because it's just a 0 ohm. A 0 ohm is just a bridge. And we can bridge that with solder. So let's just solder that up. This board really doesn't want me to finish this video. But we're going to keep at it. Get rid of that resistor. And let's get a solder bridge into here. Like that. And now we have an actual 0 ohm there. That will keep this connected with low resistance. So, but now for realsies though. Now we're going to finish this. Now it's going to turn on, right? So, hopefully one last time, pressing the power button. Thank you. Man, this board. Really taking the piss. Oh. And now, lean back and watch it turn on. So, actually, I really don't know what happened to this board. Why it was in a state like it was. With it looking gooey and all like that. But yeah, just knocked off resistor and another damaged resistor in disguise, close to where the first damage happened. And then this flaky behavior, and it is on. Let me let me build this up quickly. I want to see this in Windows with the heatsink on and with all 4 DIMMs of RAM, and then I will be closing out this video. And there we are, the board fully turned on. We have 4 sticks of RAM installed into here. We have Ethernet, we have a GPU in here. Oh yeah, just another physical damage one, but this one threw me for a loop with that additional resistor being half open. But now it fully functions. Now we got where we want to be, and yet again it shows how important physical inspection is for these ATX boards. And yeah, I hope you enjoyed the video. I hope you learned something. All of my tools, as always, are linked in the video description. Thank you very much for watching. This was Mainboard Medic, and goodbye.